I am here in Building 32 at the Johnson Space Center, and you might be able to see behind me a little bit. It looks a little like the 1960s, and if you were close enough, you could actually see where it says Lunar Plane Panel. This building is one of the national landmarks here at JSC, and why we're here is because there's two very important chambers for testing here. There's Chamber A and Chamber B. We're going to be testing today in Chamber B. Chamber B was first used back in the middle of the 1960s with the Gemini program, and Chamber A, of course, many people know about Chamber A. It was used during the Apollo testing. So we're here in Building 32, and with me today is Mallory Jennings, and she is the lead for the Suitport Human Testing, and she's going to tell us exactly what a Suitport is and why we're testing. So Mallory, tell me, what is a Suitport?
Well, thank you, Lynette. A Suitport is a new way of exploration. Currently on the International Space Station, we use what's called an airlock. And it's a separate little room that the crew members go into, get suited up, and then we remove all the air so that they go outside. The Suitport allows us to get rid of that whole room, and we just leave the suit outside, and the crew member can climb in the back and go EVA.
So why is that really necessary? I mean, I don't understand. We have a perfectly good spacesuit right now, and they have an airlock. Why change?
We think that the Suitport is going to improve exploration and EVAs, extravehicular activity, in three main ways. The first way is that it's going to allow us to reduce consumables. When you have that giant room, or the airlock, which isn't that big, but still it's pretty big, you lose all that oxygen every time you go EVA, and then you have to refill it when you come back in. So if we don't have that, we can not eliminate all of that oxygen. Additionally, by putting the suit outside and having the crew member crawl in the back and close the door and go EVA, you're able to go out for a spacewalk a lot quicker. We like to think that if you are on a planetary surface, like the moon or Mars or even an asteroid, you could see a really cool rock, decide you want to go EVA, jump in your spacesuit, pick up the rock, and then come back inside and eat lunch, and then maybe go out later in the afternoon. Which is something that our crew members now can't do. Getting ready for an EVA is a very extensive process.
And the EVAs are very long,
and very long, yeah, because it takes you so long to get ready for it, you want to get the most out of it. But now we think that we could break it up into a lot smaller segments. 15 minutes to get ready, you're out the door, stay out there for half an hour, and then come back inside if you wanted to. And then additionally, if your spacesuit's outside using the Suitport, you don't bring all of that dust or debris, contaminations inside your vehicle, which allows your vehicle to stay a lot cleaner. You don't have to worry about all of that maintenance issues.
So this is a kind of a new idea. How'd you come up with this idea? And I guess why, you've answered that, but how did you come up with this idea?
So engineers at Ames Research Center actually were the first that came up with the Suitport concept, and they started the development, and then we kind of took over it here at Johnson Space Center, and we've been testing it out kind of in its first generation capabilities out during desert rats, out on the desert, on some of the vehicles that we're testing, specifically the Space Exploration Vehicle, the SEV. And so now we're moving into our second generation Suitport. We're building everything a little more high fidelity. We've got real things that could go into space, and we're working to make it more complete. And so that's what we're doing now.
And so this is the second generation. What's different from the first generation?
So our first generation was kind of proof of concept. Does this work, and does it really improve the way we think it's going to improve exploration? And now we're testing it out. For example, our test that we're doing today is, can the Suitport handle the delta pressure that it would see in space?
So today you're ahead of human testing, but you're doing unmanned tests. So how many unmanned tests will you do before a human test?
So we really want to make sure that everything works before we put a person in the spacesuit in our Suitport. And so we're doing 4 unmanned runs prior to putting a person in our suit.
Is this the first?
This is, yeah, we're getting ready for our first unmanned run, so we're very excited.
Okay. So tell me a little bit more about the Suitport and how are you going to be testing it today? A little bit about that.
So this is our Suitport concept, which is called the Marmon clamp, and essentially it's got 2 C clamps that go and clamp on each side of a plate that's on the back of the suit. We call it the Suitport interface plate, or the SIP. And so your clamps clamp onto the SIP and holds you onto the vehicle. And then there's an inflatable seal around that keeps your pressure from leaking out from the vehicle. And so what we're doing today is we've got our suit port inside the chamber with a blanking plate, with just a plate there. We don't want to put a suit there yet until we're sure that everything works the way we think it is. We're going to reduce the pressure in the chamber down to 6.4, which will allow us to see the delta pressure across that we're expecting in space. And then we're going to actuate everything and inflate our seals and make sure everything works.
So you're testing today. We're going to be testing humans how soon?
Hopefully in a couple weeks.
Very good. So tell me a little bit about that. How are you going to make that transition, and who's going to do that?
Yeah. So we've got a very amazing team working on the transition between unmanned and manned testing, and there'll be a lot of changeovers. In a little bit, you'll get to talk to Joel Maganza, and he is actually our test director, and so he's kind of leading the effort to get that transition from unmanned to manned.
Is there anything I forgot to ask you that you wanted to talk about today?
I don't think so. We've covered what is a suit port, and hopefully that people will get to see a lot more about the suit port in upcoming weeks. We're doing a lot more publicity about it.
Well, I do have one other question for you. And tell me a little bit about your background, Mallory. What have you done here at JSC, and how long have you been here?
So I've been here about 5 years. I was a cooperative education student, so I got to go to school and then come down and work full-time as an engineer here at Johnson Space Center. Most of my time has been in spacesuits. I work in the spacesuit and crew survival systems branch, and I currently am working on the advanced suit life support system, so keeping them alive while they're wearing our new suit, and then also on the suit port team.
And what's your major in?
I'm mechanical engineering.
Thank you very much.
No problem.
Thank you, and now we'll go back to Mission Control.